My name's Tim Naish. I was the co-chief scientist on the Andrill program.
We're in McMurdo Sound in Antarctica. We're on multi-year sea ice.
I mean, Antarctica was a place I never really wanted to go. I had plenty of opportunities when I was younger. It just seemed to me as a geologist a very difficult place to do research.
The nearest land is about 35 kilometres away.
The biggest thing that you can see behind me is the tent structure around the rig itself. So it doesn't look like what you imagine a drilling rig would look like.
So here we have the Andrill drill system sitting here on the Ross ice shelf. We made a hole 84 metres deep, then we lowered our pipe through the ice shelf and a further 850 metres down to the sea floor. And from there we drilled back in time. We recovered a geological record 14 million years through sedimentary layers of rock. We got to the bottom of the hole. We had drilled 1,284 metres of core. The sort of world, if you like, the environment, the climate we're moving into, we've almost certainly experienced some aspects of before. And that's captured, if you like, as layers in the sediments that sit under our ocean that form geological strata. It's captured in there. And what we're essentially doing with drilling is we're burrowing in, we're burrowing back through time. And you can think of these sedimentary layers like pages of a book. We're turning back the pages of Earth's history as we burrow back to a window in the past that might represent where we're heading in the next 100, 200, 300 years.
Just the nature of this project, I really not sleeping very much. It's pretty much on call. You know, we're running 24 hours a day. We have 2 shifts of people working.
How deep are you now?
It's about 980 metres below seafloor, which is about 1.4 kilometres from here.
We're drilling out on the sea ice, and as that sea ice starts to warm up, we have to bring that drill rig back in pretty quickly.
We drill 6 metres at a time, and when we've drilled 6 metres we stop, we break the drill string up at the surface and we run a wire line down with a tool that goes down and picks up another tube inside that's collected the core, bring that up to the surface.
We bring up these layers core barrel by core barrel, very laborious. We are bringing back a wealth of information on what the environment was like, how warm the ocean was, what was living in the ocean, what was living on land and got washed into the ocean, like pollen. Where were the ice sheets? Were they grounded on the sea floor? Was there sea ice? Wasn't there sea ice? All this information is absolutely vital to reconstructing a picture of what our planet looked like at a time which is probably a very good example of where we're heading to.